Greetings, ladies and gentlemen. Welcome to the Music Modeling channel, and in this video I will give an overview of what type of content can you meet on this channel. I will talk about musical models, how are they classified, what are their features, how they can be implemented. Also about some practical stuff which is not covered either by musical model or by musical theory, but still which is needed to be taken into account when you actually will produce your music. I will also cover some programmatic aspects which would allow you to implement the music engine by yourself in your software, and also I talk about how to influence and rule the music which is created. Few words about myself. I am a scientist in the intersection of physics and informatics field. I'm also an old-school gamer. I spent a lot of time during my childhood and teenage years playing some canonical games, I would say. And I was doing music modeling for about 15 years as a hobby, as I cannot escape formalizing creativity which appears in my head. So, first, let's talk about classification of the musical models. At first, let's answer the question, what is a musical model? It is a formalized representation which is machine readable and quantifiable, which means everything is measured and every parameter is provided with a certain numerical value. Why they are used? For example, to formalize understanding of music, to, let's say, better distinguish it from speech, from sound. This can be useful. Also, to enhance or improve given music or generate a new one. And how this can be done? Via generative models, which often are actually replicative, and ruler-based models. Let me provide some list of features for each of these classes. Generative models include, let's say, graph models and neural networks, and they are math-based and formal and based on some mathematical idea, some mathematical representation. As a contrast, rule-based model, they provide a set of empirical rules derived from the musical intuition, and actually any set of rules which tells you what music is considered a musical model. And if we speak about advantages and disadvantages of both of these approaches, we should say that generative models are easier to implement because they are by their nature more convenient to implement. Let's say, if you have a clear idea of the model in mind and you have technical ability to do it, it's quite straightforward how it should work. And they can provide some unexpected results kind of out of a black box. For example, neural networks, they can generate images, let's say, or music, and you can not often say how they achieve this or that. On the other hand, it can contradict musical intuition because it's based on different principles, and it can be, and it actually is, biased toward the training data which you use for it. And actually it's quite hard to control because everything is done somewhere in the depths of the CPU or whatever. Rule-based models have quite the opposite pros and cons. They follow the musical intuition by design, because of this, they are easier to control because you know everything that happens inside. It's quite explicit. On the other hand, they can be non-flexible and the music can be limited and predictable if your set of rules is not wide enough. And these theories are very hard to make complete, meaning it is hard to explain everything with it because every intuition of a human is limited. What a musical model should contain? It should provide you with terms on different time scales, like note, measure, track scale, and it actually should give you the subordinate of these things, how are they organized and related between themselves. And on each scale you need to touch rhythmic, melodic and harmonica organization and probably some instrument related stuff as well. Let's go to the next part. What actually prevents you from playing music by means of musical modeling, even if you have chosen a perfect model? There are some still practical things which are taken into account by live musicians, by composers, but neither musical theory nor your musical model can tell you precisely when to use what. For example, what instrument should you use, which expressive features should you enable and when, how the equalization should be done, how you should space your instrument in left, right and in front back direction, and which reverb settings should you use. And in my further series I will provide answers to all of these questions. Let's go to the next step, some programmatical aspects of this. What the music engine does, it provides a music in real time and actually plays it, and taking into account a human input if it's possible and if it's intended. And to implement it you will need some sound library, and to implement some optimized parallelization to run your main stuff and to run music and generate and play music in the background without freezes and interruptions, and your music should not fall behind your main activity. And later on I'll show some C# examples with actual code, but these principles are quite general and then can be implemented in other languages as well. Now let's move to the next part. It's about how to influence, how to rule the music which is created by means of modeling. Actually, any input which you can provide, which you can take into account, is a huge plus, because it allows human to express themselves. So it is not kind of musical box which just playing by itself. So when you allow human somehow to intervene the music, to influence it, it's quite a different thing from autonomous playing. And in theory there are infinite possibilities of controlling this music. For example, you can provide some random number which initializes generation, which is kind of less useful and less interesting type of input. You can use normal means of PC or smartphone interaction we use every day, or you can use various sensors, which is actually the most interesting part, and I will provide examples of all of these input types. And to finalize this overview, I want to tell what I want to achieve actually and why I want to achieve this. So, I want to provide a possibility for people to make their own music without any theory knowledge, without any practical skills, by tracking or scanning their psychical intention, let's say encoded in their movements or voice, and then providing music which corresponds to this psychic intention. Okay, and what it can be used for? As we know, psychic is a source of power for any human being, and recharging one's psychic, it's a crucial intention which actually drives a lot of our activities through all our life. You can charge your psychic by different means, and actually on the top of this Maslow pyramid, which you probably have heard about, there is self-realization, some creativity, and not all people can do this actually. If you try to measure the percentage of people who can play musical instruments and compare it to percentage of people who would like to create their own music, this difference is for sure huge. And I want to bridge this gap, and this will provide people an opportunity to recharge their psychic in more creative way, to express themselves through creativity rather than food, power or sex, abusing which Freud would explain to you, they lead to wars, to many bad things, let's say. So if it would be possible to redirect the forces of the people from these lower type intentions to something higher, which is their own creativity, this should prevent some evil from happening, if I can tell it this way.